Hey guys, Mrs. Dan's here. So we're on lesson 3. I'm hoping you're getting used to this class, right? You have to write down the objective on the lines. Again, we're using those fancy words about properties of equality. Properties of equality really mean whatever you do to one side, you have to do to the other. And you can look back at yesterday's lesson to remind yourself of the order in which we like doing things. We first like to distribute. Then we combine like terms that are on the same side of the equal sign. Um, then today we're going to be doing that step that we didn't do yesterday, which is getting the variables to one side. You'll see that today's equations have like the variables. Let's say the variable is x. It has the x on both sides of the equal sign, and we don't like that. We need to get the variables to one side as quickly as possible. Then we continue like what we've been doing, and we get the constants to the other side by undoing the adding or subtracting. And then we get the variable completely by itself by multiplying or dividing to both sides. So you do now's on page 11. I would appreciate it if you paused, did it on your own, and then checked. And hopefully you do that. So this now is asking you to state the properties that were used in each step. There would be a question like this on your test asking you about properties. So you do have to know the proper terminology. So this first line here is the original equation, and I can see what was done next. Seems like the parentheses are gone, and it's because they did this thing. They use the distributive property. Next, it seems like things got kind of condensed. When I say condensed, there were 3 things on the left side, and now there's only 2 things. It looks like they combine this -3 and -14 to get the -17. So I like to say that they combine like terms. That's actually not a property. Believe it or not, I'm supposed to call it like the distributive property, but I think that's a little too hard for you to understand at this time. Let's just write combine like terms. Because that's what we call it. That's what I would call it every day, actually. Next, I can see that there's a plus 17 on both sides. They added 17 to both sides, but since they want us to talk about it as a property, we're going to use that fancy terminology now. Remember, these are properties of equality that we're using. So since we added 17, it's the additive property of equality. Properties of equality really just tell us whatever we do to one side, we do to the other, and that's what keeps the equation equal. That's why it's a property of equality. And then it looks like I divided both sides by -18. So that's the division property of equality. So I could go through the lesson really fast and get all of these problems solved and checked, but hopefully you're learning about me that I pick a few problems and go through slowly so that you can keep up with me and hopefully have a better understanding. So my theory is quality, not quantity. I don't care how many things we do. I just care about doing some things really well. So I'm going to go back actually to my plan for the day because I think about things ahead of time. So we went over the do now. I want to do numbers 1, 3, and 10 with you. And that's it. We're going to solve and check because checking is important. And we'll get those 3 classwork problems done. I think I'm going to wind up posting all of the answers to the classwork in the Google Classroom so that if you choose to do some more as extra practice, you have something you can look back at. But in this video, just numbers 1, 3, and 10. And for homework, I'm doing something similar as I did yesterday. I'm not asking you to do all of the questions on page 14. You're going to do 1, 2, 3, 4, 5 questions. Now the questions are letters, so I'm asking you to do O, E, I, L, and C. Maybe we should go circle those right now so that you're not confused about which ones I want. O, E, I, L, C. Let's go look at it. O, E, I, L, and C. Those are the ones I want you to do. And I want you to solve and check, but I want you to put your work on the next page, please. I don't want you to squeeze it on this page. I don't want squeezing. And again, if you wanted to do extra, you could, and then you'd be able to answer the riddle. But for you to get credit for your homework, you have to do those 5 questions, solve and check. Okay? You have to solve and check. I will not accept it if it's not checked. So let's go do the 3 classwork problems that I wanted to do. I already forgot what they are. I gotta go circle them. I want to do 1, 3, and 10. 1, 3, and 10. And we will have to check also. So if we follow the steps from yesterday, it's supposed to distribute first, but there's no parentheses in this problem, so there's no distributing. Just want to zoom in a little bit. Then we're supposed to combine like terms if they're on the same side. I'm going to draw this line down so you can see the sides. On the left side, those are not like terms. On the right side, those are not like terms. So there is no combining of like terms. We are up to the 3rd step though. The 3rd step says we have to get the variables to one side. So do you notice that there's an 8x on the left side and a 7x on the right side? They're on 2 different sides, and I don't like that. I can't combine them if they're on different sides. I have to get them to one side. So I'm going to use an inverse operation, which we call our properties of equality. And to get the variables to one side, it's always by adding or subtracting. So I am going to choose to get rid of this 7x. To get rid of it, I have to subtract it. But to keep the equation equal, whatever I do to one side, I have to do to the other. So I just subtracted 7x from both sides. So it's really using the subtraction property of equality. When I subtract 7 from this right side, it's gone. I really got rid of the variables on the right side. All I have is a -9 on the right side. And on the left side, an 8x minus 7x is a 1x. I could write down 1x, or I could just write down x. There's also a -2 over here. So now the variables are just on the left side. Now it looks like a simple equation. All I have to do is add 2 to both sides. And I'm left with x equals -7. So you have to get used to getting variables to one side. We have to do a check. The original equation said 8x minus 2 equals -9 plus 7x. So when we do a check, we substitute and then follow PEMDAS. So 8 times -7 minus 2 equals -9 plus 7 times -7. I like to work with one side at a time. So really, I'm going to stay on the left side. 8 times -7 negative 56 minus 2, and then negative 56 minus 2 is negative 58. That's what I get on the left side. On the right side, I have to follow PEMDAS, and I do this multiplication first. So 7 times negative 7 is a negative 49. And then when I combine a negative 9 and a negative 49, I do get negative 58. So my check worked. So you can see with a check, we actually don't know what the numbers are going to be on each side until we get to the end, because variables are now on both sides. I don't think you did equations last year with variables on both sides. So this is really a very important lesson to refer back to. You can listen to this video multiple times. Let's go do number 3. So there aren't any parentheses, so there's nothing to distribute. This is the center of the equation, and over here there are terms, but they're not like, so I can't combine them. On the right side there's only one thing, so obviously nothing to combine with. So now I'm up to the step where I have to get the variables to one side. The way that I like to do this is I like to see how many terms are on each side. So the left side has 2 terms, right? There's 2 things over here, while the right side only has 1 term. So I like to look at the side that has more things, which means I'm going to look at my left side. And I like to get rid of the variables over there and bring it over to the side that only has 1 thing. So I have to get rid of this 4m. I look at what's in front of the 4m. And the sign there, I don't see it, but I know that it means it's positive. It's like I have a positive 4m. So to get rid of positive 4m, I have to subtract 4m. These 2 things will always be opposite signs when I'm trying to get rid of something using addition or subtraction. So if I subtracted the 4m from the left side, I have to subtract the 4m from the right side. It's gone from the left. All I have is a negative 4. On the right side, negative 4m minus 4m. Those signs are the same. It's like adding, and I keep the sign, so I really have a negative 8m. I'm up to my last step, which is going to be division. Remember, my goal is to get this m by itself. So right now I have a negative 8 being multiplied by the m, so I'm going to divide by a negative 8. And whatever I do on one side, I do on the other. On the right side, I'm left with an m. People give me a wrong answer for what's on the left side. Be really careful, please. This says negative 4 divided by negative 8, and I'll tell you this, I don't like decimals, I like fractions. I'm a fraction person. I'm always writing my answer as a fraction. I look at this as the fraction negative 4 over negative 8. That's what m equals. It equals negative 4 over negative 8. But that fraction can be simplified. First of all, negative divided by negative is positive. And second of all, 4/8 simplifies to 1/2. So I would prefer to write my answer as a positive 1/2. Is it equal to 0.5? Sure it is. Sometimes though we get repeating decimals as answers, and you can't check a repeating decimal. So I need you to get used to writing your answers as fractions like I do. When you divide, I'm coming back to here, when you divide both sides by negative 8, really your answer is sitting right there in front of you. The answer is 4/8, which simplifies to be 1/2. If I go back and look at number 1 for a second, there wasn't any division. Oh, so I can't look at number 1 yet. Maybe number 10, I'll be able to talk about a fraction again. But we're not done with number 3 because we do have to check. So 4m minus 4 equals negative 4m. I'll replace the m with a 1/2. I'm going to use a dot to represent multiplication. You could use parentheses, but I'm choosing to use a dot right now. So remember, we have to follow the order of operations when we do a check. So I have to do this first. When I see 4 times a half, I like to make it look like 4 over 1. I like to simplify my fractions first. The 4 in the numerator and the 2 in the denominator, they have a common factor of 2. So I can simplify this to 2 over 1. You are allowed to simplify before you multiply. Now I'm going to multiply the top numbers. 2 times 1 is 2. I'm going to multiply the bottom numbers. 1 times 1 is 1. So 2 over 1 is really just a 2. Then don't forget I have this minus 4. I don't want to forget to bring that down. So 2 minus 4 is negative 2. I'm hoping the right side turns out to be a negative 2. Again, I'm going to make this look like a fraction. I'm going to simplify. This is 1, and this is negative 2. Then I'm going to multiply my top numbers to get negative 2. I'm going to multiply my bottom numbers to get 1. Negative 2 over 1 I can write as negative 2. Look at that. These two things are equal. I must have done everything right. And number 10. Again, no distributing, but I do have some combining of like terms. So I'm just going to draw down my line here. Do you see this side has 3 things? That's usually a hint that something can combine. If there's 2 things, you might be good, but if there's 3 things, you can combine. This negative 7x can combine with this negative 3x. They combine to be negative 10x. And I'm just going to bring everything else down. Nothing else can combine now. The left side, those are not like terms, so you can't combine anything. On the right side, those are not like terms, so I can't combine anything. So now I want to get the variables to one side. You get to choose, really. Don't write this down, just watch for a second. I'm allowed to add 10x to both sides, and it would make me cross off my x's from the left side. Or, don't write anything down, remember, just watch with me. Or I could have chosen to add 4x to both sides, and it gets rid of the x's from the right side. You really have your choice. When there's variables on both sides, you pretty much always have a choice. And you might do it one way, and your friend might do it another way, but honestly, you get the same answer either way. So I'm going to show you that the choice is up to you and it won't matter. So let's first add 10x to both sides. Please write this down now. It causes me to get rid of the x's on the left side. I also want to point out when I wrote plus 10x on the right side, I made sure I wrote it underneath the thing it was like so that I can do a negative 4x plus 10x to get 6x. Now the rest of this is pretty straightforward. We have to add 24 to both sides. $12 plus 24 is 36, and I still have a 6x on the right side. And then my last step is to divide by 6 so that x equals 6. I'm going to show you that if I did my other choice before, I'd get the same answer. So I'm not going to do number 9. So I'm just going to use this space over here to do number 10 again, using a different choice and proving to you that really the choice is up to you when you're trying to get variables to one side. So I still have to combine these. Now, what if you made the choice of adding 4x instead? Then over here, negative 10x plus 4x is a negative 6x. Now what I have to do next, because of my choice that I made just a second ago, I have to now subtract 12 from both sides. So it looks like I'm solving the equation differently than before, but I just wanted to prove to you that I will get the same answer. A negative 24 and a negative 12 is a negative 36. But look, now I'm dividing by negative 6. And negative divided by negative is positive, and 36 divided by 6 is 6, so I actually still get that x is 6. So when you're trying to get variables to one side, you have a choice. Pick one of the variables. You can't be wrong, and do the opposite to it, and then just follow through your equation like normal. Right here in the middle, I'm going to do my check. I only have to do one check because it's the same question. I just have to start with my original question. So it was negative 7x minus 3x plus 12 equals negative 4x minus 24. My answer is 6, so in place of x, I'm going to put a 6. I'm going to stick to the left side for now. This is a negative 42. This makes me write down minus 18 plus 12. I'm going to work from left to right. Negative 42 minus 18 is negative 60. Negative 60 plus 12 is negative 48. I'm hoping the right side turns out to be negative 48. Negative 4 times 6 is negative 24. And I bring down the minus 24. And then negative 24 minus 24 is negative 48. I'm just going to write it way down here so I can put an equal sign and put a check. So that's it for today. Please make sure you solve and check the 5 questions I asked you to. You can send me any questions you have, and I'll get back to you as soon as I can. Have a great day. Talk to you soon. Bye.